the organizers, the various speakers, and fellow conferees. You are welcome to the Faculty of Engineering 2020 International Conference. Theme: Sustainable Engineering and Industrial Technology. Organized by the Faculty of Engineering, University of Nigeria, Nsukka, Enugu State, Nigeria. My name is Engineer Dr. Cornelius, Agbo, and I will be discussing my paper titled Empirical. So right away we go to the introduction. Why the interest in Strand mat composite? One may ask. Strand mat composite have gained popularity in design and construction as alternative structural and non-structural materials. Their comparative advantages lies in the fact that they are cheap compared to other architectures, with excellent strength to weight ratio. They also have resistance. They can be easily manipulated and tailored to the shape you want during manufacturing. They have also good damping and impact energy. Then we look at the knowledge gap and the justification for the study. Knowledge gap in the literature. It is apparent that mat composites have received less attention compared to other fiber architectures in its modeling, despite wide application. Therefore, this experimental research work is used to model the tensile strength and modulus of the chopped strand mat composites needed during design. In the literature, there are models developed based on rule of mixtures and modified rule of mixture, operating one factor or the other. They are basically developed from the mechanical properties of the constituents. Cox and Crenshaw incorporate bed fiber orientation, μ0, and fiber length efficiency factor, ULE, in the stiffness model, while Kelly and Tyson modify the strength with the same factors. That is fiber orientation and fiber length efficiency. Also, DG developed stiffness model of the mat composite using unidirectional parameters. This, if you look at it, it is a bit complex, and that's why we have decided also on a simpler methodology. In our experimental modeling, we started by developing or producing coupons. Materials used includes e-glass chalk strand mat, unsaturated polyester resin. The catalyst is methyl ethyl ketone peroxide. The accelerator is cobalt. The method used, coupons were produced using the hand lay-up technique. Tensile tests of the specimens were carried out according to ASTM, American Testing and Materials, D638 standard for tensile properties of plastics. Results and discussion. Here you can see the initial modulus was plotted against the fiber volume fraction employing the rule of mixtures mode. DG model and other, and you can see that the rule of mixtures and the DG model, the empirical data was fitted with a linear model, and you can see that a linear model actually an acceptable plot. Also, a linear model was developed, and this model put in the form of equation is compute the modulus of a fibre-mat composite knowing the constituent properties of the volume fraction. Also, the tensile strength plot against the fiber volume fraction yielded a quadratic model which is presented in equation 8. This model ensures that the strength decays at above 20% fiber volume fraction. This is typical of a real fibre-mat composite. If you look at the other models, they have a linear model with fiber volume fraction. This can be because for unidirectional, yes, but for fiber mat, the orientation of the fibers are not in one direction. And when you start pulling them, some are not actually contributing, especially with the increases in fiber volume fraction and less binding. And so you start losing strength with more fiber volume fraction. So with this, gentlemen, I say thank you for listening. God bless you.